Hi, in this video we're going to find the inverse of a 2 by 2 matrix. So in matrices there is no such thing as dividing matrices. Instead of dividing we use inverse. We multiply by the inverse instead of dividing. So that's why inverse is important when we learn about matrices. So here we are only going to discuss about how to find the inverse of a 2 by 2 matrix. So let's say I have a matrix M and the elements are denoted by A, B, C, D. Okay, so the inverse of this matrix M inverse denoted by a -1 like an exponent up there is given by 1 over determinant of M times the matrix D, A. I flip the position of the diagonal elements here, and the C and B stays in its position, but they will change the sign. So this is the formula for the inverse of a 2 by 2 matrix. So first step is you have to find the determinant of the 2 by 2 matrix. We know the determinant of a 2 by 2 matrix is given by the difference of the diagonal elements, right? Starting from the top left, AD minus BC. So you find this determinant first, and that goes as a fraction in front of this 2 by 2 matrix, 1 over the determinant of M. Now since this determinant of M is in the denominator, this number cannot be equal to 0. The determinant of M should not be equal to 0 in order for the inverse to exist. Because division by 0 is not defined, therefore M inverse will not be defined. So a matrix is invertible, a matrix is said to be invertible only if the determinant of that matrix is not equal to 0. Okay, so if it is 0, you will not be able to find the inverse. So let's do some examples now. Example number 1, I'm going to put as 6, 2, 3, 8. I'm going to give a 2 by 2 matrix. Let's call it matrix A is 6, 2, 3, 8. And we have to find A inverse. That's the question. Okay. So the first thing we need to find, step 1 for this would be to find the determinant of A. Find the determinant of A. So the determinant again is a cross multiplication of 6 times 8. 6 times 8 minus the cross multiplying that way, which is 3 times 2. So 6 times 8 is 48 minus 3 times 2 is 6. So we will get our answer to be 42. So here the determinant is not a 0, it's a number other than 0. So we can definitely say that the matrix A is invertible. Or we are able to find its inverse. So let's see. The second step is to, in the second step, we can write it out like this product, like a fraction, and the new matrix 2 by 2 matrix that we need. Okay, so to find A inverse, I have to multiply 1 over, as per this formula over here, I have to multiply 1 over the determinant of A, and then I have to multiply it to the matrix in such a way that I switch the A and the D. These two will switch its position. Okay, position. So the D will go up and the A will come down here, and C and B will change the sign only. They will not switch their positions, they will only change their signs. So here in the place of A and D, I have 6 and 8. So 8 will go up and 6 will come down. This diagonal would switch its position. The other diagonal, the 3 and 2, they're both positive numbers, will change to -3 and -2 instead. So that's the only difference. So here we just found out that the determinant is 42, so we can replace the determinant of A by the number 42. So this is step 2. Okay, in the formula we replace the determinant with the value and we change the position of this first diagonal and change the signs of the second diagonal. So then all you have to do is step 3 is to multiply this 1 over 42 to each element inside this matrix. To each one of them we have to distribute the 1 over 42. So the first one becomes 8 over 42, the next one becomes negative 2 over 42, and then we get negative 3 over 42, and then 6 over 42. At this point we can just see that some of the fractions we can reduce it. So let's do that. 8 over 42, they both divide by 2, so we get 4 over 21. Negative 2 over 42, they both divide by 2, so we get negative 1 over 21. Here, negative 3 over 42, 3 goes into 42 14 times. I don't think I can write 3 again, that should have been a 1, sorry about that. So that should be a negative 1 over 14, so because 3 goes into 42 14 times. And then 6 divided by 42 is reduced as 6 goes into 42 7 times. So 1 over 7. So that's the answer to the inverse of matrix A over here. A inverse is equal to this 2 by 2 matrix. Let's do one more example. Let's say matrix P is given to be elements are 2, negative 3, and 4, negative 1. Okay. We have to find P inverse. So first step, we have to find the determinant of the matrix, determinant of P. So to find determinant of P, we have to multiply this diagonal 2 times. Let me just draw over the numbers. So let's draw like that. 2 times negative 1 is negative 2 minus 4 times negative 3 is negative 12. So it's negative 2. These two negatives will make it a positive 12. So the determinant is the number positive 10. So of course this matrix is invertible and we can find the inverse. So to find P inverse now, we have to write 1 over 10 or 1 over determinant of P times, I have to switch this matrix around. Okay, the 2 and the negative 1 will change its position. Negative 1 goes up, 2 comes here in that diagonal. Now in the other numbers, 4 and negative 3 will only change their signs. Positive 4 will become negative 4. Negative 3 will become positive 3. So once you write it like that, we have to just distribute the 1/10 to each element in the matrix. So it becomes negative 1 over 10, 3 over 10, negative 4 over 10, and 2 over 10. Let's reduce here any fractions that can be reduced. So the first one would be minus 1 over 10, and then 3 over 10, nothing can be reduced there, but in the bottom row, second row, we can reduce it by 2. So that's 2 over 5, and 2 over 10 can be reduced as 1/5. So that is the inverse of question number 2 of matrix P. Let's try one last question. Number 3. Let's call it matrix Q, which is equal to 4, 6, 2, 3. Find Q inverse. So our first step, find the determinant of Q. So in order to do that, I got to multiply 4 times 3, 12, minus 2 times 6, which is also 12. So here, when I find the determinant, I get my answer as 0. So that means when I find Q inverse, I have to do 1 over determinant of Q, which is 0 with the matrix. So since there is a 0 in the denominator of a fraction, it will be undefined. So we have to say that this matrix is not invertible. Okay, we are not able to find its inverse, not invertible. So that's it about 2 by 2, the inverses of 2 by 2 matrix. How do you find the inverse of a 3 by 3 matrix is for another video. It's a little bit longer than the inverse of a 2 by 2 video.